Use the method of virtual work and determine the horizontal deflection at C. EI is constant. There's a pin at A. Assume C is a roller and B is a fixed joint. A to B 3 meter, B to C 1.8 meter. We have distributed load in at B and C. Distributed load is 6 kilonewton over meter. Okay, there is 3.3 times cosine 45. There is 3 times sinus 45. It's equal 2.12 meter. Let's draw free body diagram. Body diagram. We have AY, B point and CY, and distributed load 6 times 1.8. It's here 10.8 kilonewton, and there is 0.9 and 0.9. Let's moment A. Let's take moment A point. Moment A equal to 0. There is 2.12 meter. There's 0.9 and 0.9. CY times 3.92 times CY equal to 10.8 3.02. Okay, 0.02, and CY equal to 8.32 kilonewton. Total Fy it's equal to 0, and CY minus 10.8 plus AY it's equal to 0. AY equal to 2.48 kilo. Let's cut from A to B. This distance we assume x, and AY equals to 2.48 kilonewtons, and components for the moment. This reaction is 2.48 times cosinus 45, and it equals 1.75 kilonewtons, and we find the moment at this point. Moment equals to 1.75 kilonewtons times x. (1.75 x kilonewton times meter. Okay, let's cut from B to C. .8 kilonewton. Sorry, we have to draw distributed load. 7 kilonewton over meter, and Cy equals to 8.32 kilonewton, and this distance is x. Total moment for this point equals to Cy times x, minus 6 times x and its midpoint, and this distance x over 2 times x over 2, and 8.32x minus 3x square and 3x square. Yes, okay. This value for distributed load, we have two different moments we find, and applied load. Let's draw the figure, and there is 1 kilonewton applied load, and Cy we have Cy and we have Ay. Okay, this distance for 1 kilonewton, 2 point okay, 2.12 meter, and Cy for this distance and 3.92 meter. Okay, take moment for at point A. Moment A equals to 0, and Cy times 3.92 minus 1 times 2.12 meter, and it's equals to 0. Cy equals to points 541 kilonewton. We have only two Fy, Cy and Ay, because of Ay equals to minus 0.541 kilonewton. Okay, let's cut A2 from A to B. Okay, there is Ay and 0 point, the arrow looking down, 0.541 kilonewton, and this is components times cosine 45, and there is 0.541 383 kilonewtons. We have moment and this distance, assume x. Okay, this moment equals to 0.383 times x. Let's cut from B to C. We have Cy. It's equals to 0.541 kilonewtons, and x, we have only this force, and moment equals to Cy times x. So 0.541 x. Okay, let's determine the horizontal deflection at C point. Horizontal deflection at C point equals to integral L0 from applied load moment times for distributed load moment over EY. EY equals constant, EY is constant, times dx equals to integral 1.8 for BC. Applied load moment for BC is equals to 0.541 x times moments distributed load for BC 8.32 x minus 3x square over EY times dx plus integral 0.3 for AB. Applied load for AB moment 0.383x times for distributed load moments A to B 1.75 x over EI times dx. After the calculation, 1 over EI times 8.748 minus 4.26 plus 6.03, and deflection, horizontal deflection at C equals to 10.518 over EY kilonewton meter cube.